Hi, it's Jan Beta, and I'm going to put a relay into my desoldering station today. This is my ZD-915 or ZD-915 desoldering station or desoldering station, depending on where you live and how you pronounce that. I did some mods to this. I put a DC to DC converter in here for proper voltage, a new fan. I wired up the power switch a bit better to switch 2 wires instead of only one, only the live wire. It has been working well since I did the mods. No complaints, but there's one thing that I think I mentioned in the previous video about this, where I did the other mods, that I want to address today. So the way this works is basically you have this station that has an air pump in this and all the regulation, temperature regulation and power supply, things like that. And then you have this gun part that has a little action button here, trigger, to actuate the pump in here. And then there's a hose that connects the suction from the pump to the tip here through this glass tube. And we have a cable that consists of 6 pins, I think, in this case. And the design flaw that this has is that basically the power that actuates the pump runs all the way through this wire to the switch, goes through the switch and back through this long wire, and then the voltage gets to the pump and it actually activates the pump for the suction. So that is a very long wire, or 2 wires actually, and we can circumvent that with a mod that I found in the same forum I found the other mods in. I'm going to link that again below, by just letting this trigger here switch a relay, and the voltage for the pump is switched by the relay closer to the pump without any long wires. So we won't have any losses through the wire lengths. And this is probably going to be the final mod I do to this, but I wanted to try this, and I like big chunky relays with a satisfying clicking sound. So I got a 12-volt Automotive relay actually. That is just one switch. In case you don't know what a relay is, you put voltage through a magnet and that closes a switch physically through its magnetic force, and then that switch switches what you actually want to switch. So these can be used to use a low current, low voltage input signal to switch something higher current and higher voltage. That's the main use case scenario for this. This is a really beefy one, rated at 30 amps. The important part is that it's rated for 12 volts input. So you need 12 volts through the coil here to close the switch. And that is the exact voltage we set our DC to DC converter to power the fan and the pump. So the only thing that we changed really is to let this switch only switch the magnet in here and not the actual voltage that goes to the pump. If that sounds confusing, maybe it's going to become a bit clearer while I do it. This is basically what we are going to do. This is our pump. It needs a positive and a negative voltage. On some stations, as I've read in your comments for the last video, the pump voltages are reversed. There's actually a little plus marker on the pump, but on some stations the polarity was reversed, so you want to make sure to measure that and connect the correct wires. Yeah, this is our trigger in the gun part of the whole equation. Then this is our DC to DC converter in this case. The positive voltage goes to one of the pins on the switch, which is actually switched from no connection to connection, and that goes to the pump. That's switching the pump on, and it also goes through our switch to activate the magnet through this coil here. So this, if you apply voltage, positive voltage on pin 86 of the relay and negative voltage on 85, this is going to activate the electromagnet and close this switch. That's all that's to it. And of course you can do the same with a transistor-based switching circuit, which is of course a bit more elegant and it doesn't click, but I like the chunky feel of this. And these are automotive grade parts, so they are going to switch a lot of current very reliably for a long time, for many, many switching cycles. I think these are rated at around 10,000 switching cycles, and that's only the guaranteed rating. This is going to last a while, and this is a good brand one as well. Hella is a pretty well-known brand. You see all these rally cars with Hella branding and things like that. So this is a proper automotive relay. If you buy one of these, they're not very cheap, but they are a couple of euros. You want to make sure that you get one that uses 12 volt for the magnet, for the switching voltage. There are also versions of these with 24 volts, and there are also versions that switch more than one wire, basically a dual switch here, but we only need to switch the positive voltage in this case, so this is the one we got. 2 connectors for the coil and 2 for the switch. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do CNC machining, 3D printing, sheet metal fabrication, injection molding, basically everything the tinkerer needs. The pricing is super reasonable, they are friendly people to work with. I highly recommend checking out the link in the video description. Back to our ZD-915 mod bonanza. So, opening this up again, one more time. Probably not the last time, but at least the last time for modding it. Maybe it's going to need some repairs next, I'm not sure. I didn't use this for a long time with the mods in there, so I'm still not sure if the mods are going to hold up in the longer term, but I think so. And we're in! And of course we need access to our switching pins, which are pins 5 and 6 usually. This is pin 5, this is pin 6. There are different versions of this gun part that some of them have a different pin count. So I think there are versions with 7 pins, but the original ZD-915 has 6 pins, and this is that version. I think 5 and 6. 6 is the center pin and 5 is to the side here. These are the wires going through the trigger. We can quickly test that with a multimeter. I think I should probably do that. Don't even have to power anything on. So multimeter is in continuity testing mode. Should beep when I close the switch, holding these probes in the connector there. Yeah, and that's clearly where our switch is. Pins 5 and 6 on this. And now we only need to make sure that we find the correct pins on the other end. So this is my DC to DC converter in there. This is one of the wires that goes to the pump. Yeah, 2 wires from here. One is the positive, which is this one. I marked that red, and it goes to the positive terminal on the motor, which is actually the positive terminal on mine. We are also going to do the same that we did with the motor, with the relay, because that is also an inductive load, much smaller one than the motor, but we're going to put a flyback diode over the pins there to make sure that our DC to DC regulator doesn't get backwards voltage when the relay switches, which is going to happen quite frequently. I'm going to have to check my wiring diagram again, but I think these are the wires that we need at first. I am going to take the front panel off here, which is just held in with 2 screws. We have disconnected it. Yeah, we have 2 pins that are switching. This comes directly from the power supply. That's for our heating element. These are a bit thicker wires. Are these the wires we're looking for? Could be this one. So I'm just going to measure on this here, I think, and see which wire is which. So pin 6 is the center pin, which is also the same here. So let's see where that goes. Yeah, we have to dismantle this a bit further, I think. And we can take the whole front plate off, I guess, and then follow the wires. So we can take this off with the switch, and now we have better access to our wires here. So 5 and 6. This pin 5 is this one here. This is actually the one that goes to the motor. Yep, that's pin 5 for you. And pin 6 is the one that goes to the DC to DC converter. Okay, I see. So this is pin 6 and this is pin 5. This is our pin 5 and our pin 6. And this one, the pin 5, is the one that goes to the negative of the motor. And pin 6 is the one that goes to our DC to DC converter. So if these two are closed through the switch, through the wires in the gun, yeah, voltage is going to flow through the motor. That makes sense somewhat. We're going to have to cut these, I guess. I'm not going to solder to this switch here, or to this connector. We're going to have to cut these and connect them to our relay. So this is just going to be cut, and this is just going to be cut. And these are the wires coming from the switch. And it doesn't really matter which one is which, because we just need to switch our voltage, basically. Yeah, we could also put the relay somewhere here, I guess. Need to come up with something. Possibly, this is a good spot, if that fits with the pump and the motor. Just attaching it to one of the screws that hold that front plate in. There should be a bit of room there. Just need to make sure that the hose gets through there. Yeah, that would actually be cool. And this pin 5 is actually the one that closes the positive to, yeah, that closes the loop. You are just going to have to read the manual yourselves. So what we want to do is to have current flow through our coil in the relay. And so what we need to do is to connect pins 85 and 86. We need to connect the positive voltage from the DC to DC converter to the switch and one of the pins. So the trigger and one of the sides of the relay. We need to connect it through the switch to the relay, and the negative of the pump is connected on the other end. Just going to make a lot of wires a bit longer here, I guess. So 85 and 86 are these contacts. So the positive goes to pin 87, and it also goes to the switch. That's our input voltage. Yeah, so what we basically have to do is to wire these both up to pin 87. And then pin 5 is switching the positive voltage through this. Yeah, that's what's supposed to do. We're going to have to make that a bit longer so we have more room. And don't worry, I'm going to explain that a bit further once I understood it. So I'm just going to connect these here. Yeah, that looks good. Some heat shrink tubing. So that is our positive from our DC to DC converter. And that goes both to pin 6 on our switch and to pin 87 on our relay. So we're just going to connect these. And I think I might crimp a connector on there. And what are these? 6.3 millimeter? Yep, they are. It's going to be way more resilient than we need it to be. Yep, that's pin 5. That's connected to pin 86. Yep, looking good. Then we need pin 85 from our DC to DC converter. Ah, that's the other wire from the DC to DC converter. And this one is going to be connected to pin 30. This is pin 6. And that goes to our switch. I'm so confused. So this goes to pin 87. Yes, that makes sense. I'm going to explain in a second. So I'm just sanity checking here, and I think I reversed the wires because this is the negative wire coming from the DC to DC converter. This is the positive. If I'm not mistaken, I'm just going to have a look. Unfortunately, the connections for the output are on the bottom side here. So yeah, we need to reverse some wires here. But that's no big deal because we crimped all those connectors. Okay, so we need to swap this wire with that wire. We're going to do that again. And I think after that, it's time to explain how this is wired up. Okay, so now this is our negative, and that goes to the negative on the motor, and our negative, and that should go to pin 85. Okay, so this should work in theory. We have to put our flyback diode on our relay though. Forgot about that. So I'm just going to remove all our connectors here again, in the hopes that I wire them up correctly the next time around. And we're going to solder our diode across the contacts directly here. Between pin 85 and 86. Pin 86 is our positive, so the negative side of the diode should go to that. Like so. And like so. And we're going to solder it kind of close to the bottom of the connector there, so we can still make good contact. Yep, that should be on there. And now we have our diode in there. Bit shoddy, but it's all right. And I think we're going to wire this up and see how it fits in the case first before I do anything else. We can easily remove the wires again. So now, as I said, we are going to wire our minus on the pump to pin 85 on the relay, which is the one the diode is facing away from with the ring. So the ring is not there, but it's connected. The other end of the relay is the pin 6 on our little switch in the gun. That's the other end the diode is connected to. And this is our coil for our magnet. And then this is the positive end of the motor that goes to pin 30. And this is the positive end from our DC to DC converter, and that goes to pin 87 and also to pin 6 on the switch. So that is 87 on the relay and pin 6 on the switch. So this should be wired up according to plan, if I got everything correct. Let's try it, I guess. Yeah, and I wanted to connect this here, like something like this, which should be totally possible. Let's try that. Just going to put a screw back in there. Kind of at an angle here. Yeah, that's actually not too bad. I'm going to see how that goes. And I'm definitely going to put heat shrink over those contacts once I have determined that this actually works. So this goes back on here. Maybe this all just blows up. Or at least it blows the fuse. It is, thankfully everything is fused. Even the DC to DC converter has an extra little fuse in there. So we should be good regarding damaging this permanently. Okay, I think I might be ready to try this out. Put power to it. Still beeps. Gun still heats up, I guess. Yeah, it still works. We're going to have to measure the voltage on the pump though. I think probably it's a bit higher now than what we set it up for. It sounds a bit faster at least, because the action is way more direct now. Of course, the wires have a bit of resistance, so we're going to have to accommodate for that. But yeah, I don't hear the relay clicking because the pump is actuated by the relay, and that's louder than the relay. But it should give a little click, in theory, that we just don't hear. So I had this at slightly over 12 volts the last time around. I've hooked up my multimeter to the motor directly. Yeah, that's way more now. That's 13.4. So let's turn it down a bit. So I'm going to set it for this here, 12.56. This is going to be more than enough. And the suction should be more direct now, because we don't have any losses in the cables. That worked out surprisingly well. Let's put everything back together, and I'm going to let this cool off now because this is heated up to at least 300 degrees Celsius, if I read that correctly. We need to wait for a while. I'm going to put some cable ties in there again and some heat shrink tubing over the contacts on the relay, actually. The spade connectors there need some protection because they're just floating in there, and I don't know how well that thing is going to hold with that one screw there. This is how I put this in there now, by the way. Not too bad. That's one of the screws that's holding this little bracket that holds the power switch in place. And actually should hold pretty well, and it's out of the way of everything. So just disassembling our test setup here again and putting some cable ties and some heat shrink tubing over these connectors. That means I have to disconnect them again. Yay! And I just did one connection at a time so I don't get them confused, which was probably a good idea. Yeah, cable ties, routing the wires, and then putting everything back together. And never forget to connect the suction hose here to the front panel. Now for some real-life testing of the finished product, I just got out my C64 spares board. And this has some empty RAM chips on here that I want to desolder. Suction is super nice, even though I didn't clean it really. What I usually do is to use some hot air to get it all out. But in this case, we're just going to use brute force. I would say that was a success. So that was the final mod I want to do at this point to my ZD-915 desoldering station. As I said in previous videos, I still like this station very much, and it's money well spent if you don't want to spend too much on a desoldering station. These are not as expensive as good brand ones, and they are nearly as good except for the fact that you have to clean the guns pretty often, and it's a bit of a painful experience. But if you do that and you get used to it over the years, you're going to have a really reliable tool, just with some little quirks. That's it for today. Hope this was informative and maybe inspires you to do some hacking on your ZD-915. This relay mod is entirely optional, I'd say. The DC to DC converter mod is far more important for what I do here, and it actually improves the performance of this. And also, new fan doesn't hurt because the original fan is just crap. Thanks so much for your time. Special thanks, as always, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page, and who gives me single donations through super thanks and things like that, or on PayPal. The links to that are in the video description. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.